Welcome to Calc Chat 42. Today we're going to be talking about net change. First, we need to recall the position, velocity, and acceleration functions. When we first encountered these functions, we learned that position is generally written as s of t, velocity is written as v of t, and acceleration as a of t, where t is some time. And we know that our velocity is the derivative of our position function, and our acceleration is the derivative of our velocity function. So if I was, say, given the velocity, or let's say I was given the velocity function, and I wanted to get back to my position function, I would need to integrate, not integrate both sides, integrate my velocity function, and that would get me back to my position. And same idea with acceleration. If I integrate my acceleration, you should have dt's, I should get back to my velocity function. And so we're going to use this idea to help us kind of calculate how, basically the difference, how much things have accumulated over time. And this accumulation we call displacement. So if I am walking from point A to point B, and then from, let's say, B to point C. From point A to B is, let's say, 5 miles. From point B to C is 2 miles. My total displacement from A to C is going to be 7 miles. And so displacement is this idea of kind of, we're adding up each mile and we're taking the total distance traveled. And so that's the idea of displacement. How far are you from where you started? From where you started. And so we're going to be dealing with this with distance as well as kind of some other things. So here's an example where we're given that a particle has an initial position of 9, and we're given the velocity function is t squared minus 8 over t plus 1 squared. And we're asked for the particle's position at time t equals 1. So the first thing I kind of want to figure out is I know my particle starts at 9. And at t equals 1, it's going to end up somewhere else. And so if I can find the displacement, maybe how far it's traveled, I can figure out where it has ended up. So we're going to set up an integral first in order to find the total displacement. So we're going to integrate t squared minus 8 over t plus 1 squared. And I'm going to tell you that this is going to be negative 11 over 3. So I know that unfortunately I don't know unfortunately, but my particle has moved backwards 11/3. And so in order to find where my particle is at t equals 1, I take my initial position, and in this case it's negative minus 11/3. And so this is the particle's position at t equals 1. So here I'm asked for the total distance traveled. So in the previous example, I was asked for the particle's position. I used the displacement. Displacement can be positive or negative, but since I'm dealing with total distance traveled, I need to take the absolute value of this integral. Sorry, not of this integral, of my velocity function. So I want to set up the integral from 0 to 5 of the absolute value of t squared equals 8 plus 1 minus t dt. And so this is another one. We're just going to plug in the calculator, 42.59. And so this is how far the total distance my particle has traveled. So here's kind of your DIY. This one's a little bit different than the ones that we were doing before. Again, I'm going to kind of walk through this at the end. But we're given the problem that from noon until 6, people enter an amusement park at a rate described as E of t, and they leave at a rate described as L of t. And at noon, there are 3,000 people in the park. T equals 0 corresponds to noon, and T equals 6 corresponds to 6 p.m. And then we're asked to set up an integral expression to describe how many people are in the park at 6 p.m. So go ahead and see if you can use what you've learned in the previous slides to help you set up this integral expression. Notice I said integral expression, not singular integral, because you might need more than one. So go ahead, pause, try it out, and then I'm going to have our solution right on the board. So this is what your integral expression should look like. 3,000 plus the integral from 0 to 6 of E of t minus the integral from 0 to 6 of L of t. This idea of accumulation, from 0 to 6, we're adding in the people that are entering, and then we need to subtract the total number of people that have left, plus I had 3,000 to start with, and so that's going to be my integral expression. So this is it for net change and displacement and accumulation. So please make sure that you write down any questions that you have, anywhere that you're kind of lost in. And thanks for watching, and be sure to like and subscribe.